So in this video, we're going to be talking about solving one-step equations. Okay, and so to solve an equation, you must, so to solve an equation, we must first isolate the variable by using inverse operations. So what I mean by that is, for instance, addition and subtraction are inverse operations, and multiplication, division are inverse operations. So if there's an addition sign, the inverse of that would be subtraction, and if there's like a division sign, the inverse of that would be multiplication. So some examples would be, just for example, the equation x plus 2 equals 7. This is only one step. So right now we have a plus 2 right now. In order to solve this equation, we must minus 2, and when we minus 2, we have to do it on both sides. You'll put that line to help you stay organized. If I do something on the left side, I must do that to the right side as well. And that would give x equals 5. So our answer is that x, the variable x, means 5. And if we can check this by plugging in, substituting 5 for x, and we would get equals 7, and 7 equals 7, and that's a check. It is true. So it means we did it right. This is our check right over here. Another example would be x plus 9 equals 15. Now you can draw that line in the middle to help you stay organized. And we would do minus 9 minus 9. And we would get x equals 6. And in order to check, so we could write beside check, we substitute 6 for the x and get 15 equals 15, and that is right. Now let's do one with subtraction. And let's do y minus 5 equals 7. Now the inverse of subtraction would be to add. So we're going to be adding 5 to both sides. Now this cancels off, and now we have just y equals 12. So again, we use inverse operation, and we're going to do check on the side, and we're going to substitute 12 for y. And when we get this, we did 7, and 7 does equal 7, so that is right. Let's do another one for subtraction. Well, actually, let's do addition. Let's mix it up a little. And let's get a plus 8 equals 16. Now for this one, we would do the same thing. We would make the line in the center. The opposite of plus 8 would be minus 8. So we would do that on the both sides, and we would get a equals 8, and we can check on the side. And we would do, okay, we substitute 8 plus 8 equals 16. We would do this. Yeah, 16 equals 16, and that is true. Okay, now let's time switch up it a little bit, and let's put the variable on the right side. This shouldn't really change our answer. We would still be able to do the same steps. So we would be, what's the opposite of minus 14? And that is plus 14 on both sides. And we would be getting 39 equals what? And we could do a check on the side. And we would be substituting 39. Oops. That would be 25 equals 39 minus 14. And when we do this, we get 25. And this is true. So let's do a different one. Now let's do something different. And let's do d minus 1/3 equals, let's say, 1/6. So for this one, what you will be doing is you can do the same thing. Since it is a minus 1/3, you would be doing plus 1/3. And if we recall from adding fractions, what we have to do, since they're not in a common denominator, we would be first trying to make it a common denominator. You could do it off to the side, but you know that third, you could just have to times this by 2/2, and you would be getting 2/6. Now we would just be adding 1/6 to 2/6, and that would is 3/6 equals d. However, it is the best to simplify this, so we're going to simplify this to just d equals 1/2. And this is your final answer over here. Now, if you want to check this, which we could still do, I'll just do opposite side over here. Try to do a little tinier. Okay, so we would do 1/2 minus 1/3 equals 1/6. Since they're not like terms, I would just transfer them into 6. So that gives us, when you do that, 3/6 minus 2/6, and that gives me 1/6. 1/6 does equal, so that works out. Now let's do something different. Now we've done quite a few examples of add, addition, subtraction. Now let's do multiplication, division. So 2x equals 16. For this one, right now we're multiplying. There is an imaginary multiplication sign in between the 2 and the x. So what we're going to be doing right over here is, what's the opposite of multiplying? So we use over here inverse operations. So what that meant was add, addition, and subtraction, multiplication, and division. So those were the inverse. So the right now for multiplying, this is, I'll make a note to the side. You're multiplying. So you are multiplying. Multiplication. So with the opposite of that would be dividing. All I'm going to do is put that bar underneath the division and divide by 2. When I divide both sides by 2, my 2's cancel off, and I'm left with x, and 16 divided by 2 is 8. So x equals 8. You could do the same thing over here to check your work to make sure you are right. You're going to be doing 2 times 8. You could use those parentheses if you want, or you could just write the multiplication sign, but I would recommend doing the parentheses. But it really doesn't really matter. And 2 times 8 is 16 equals 16, and that works out. Let's do a couple more. Now let's do a different one. It's a little bit different. Let's do x divided by 3. Remember, this fraction bar is another way of division. Equals 4. Now, the opposite of division would be, because this is showing us to divide, right over here, this is dividing. What we're going to be doing now is we're going to be multiplying. So we're going to be timesing it. You can use a dot, or the dot is another way for multiplication sign, or you can just use the multiplication sign. So I'll write that. And you're going to be doing, I can't really be timesing this by, so what I'm going to be timesing is by its reciprocal. Pretend that this is a 1. The x means 1. You're going to be just timesing by 3, or you could just say 3 over 1. And it'll cancel off. You could just put that 1 underneath if you would like, because 1 times x is x. And if I do here, we do times by 3, and that gives me 12. And I can check this work. I can write over here on the side, check. Check. 12 divided by 3 equals 4. Well, 12 divided by 3 is 4, and 4 does equal 4, so we did it right. So here again, we're going to be timesing it really by its reciprocal. You're just going to be timesing it by whatever that number is and over 1. And that should cancel off, and you would just be left with x. So let's do a couple more examples of that, so we'll be a bit more familiar. Okay, so now let's do w over 4 equals 12. Now I will be timesing this by 4, or you could put that over 1, and this would cancel off. Now I would also do the same thing to the other side. And I'm left with w, because that isolates. 10, okay, this equals 48. This is my final answer. I could always check. Let's do 48 divided by 4 equals 12, and that gives me 12 equals 12, and that is right. Now let's do 3 more examples, and we will do 3 more examples. Okay, so let's do 144 divided by 2 equals 2x. Whoops. Equals 2x. So this one, 144 equals 2x. So for this type of problem, you're going to be saying, okay, this one is multiplication, so I must divide both sides by 2. When I divide both sides by 2, I would get, this is an easy, well, now I'm just left with 72. I can check over here. And for that, I would just say 144 equals 2 times 72. And I put this in the calculator, or you can just calculate in your head. I do get 144, and that is right. 2 more. Okay, let's do something with decimals now, and let's do 12.5n equals 32. So for this, same thing goes here. If you're multiplying, now I must divide by both sides by 12.5. And when I divide both sides by 12.5, this cancels off, and I get n equal, let's see, that gives me 2.5. And if I check, that would be the same exact thing over here. I would get 12.5, and so the n gets substituted for 2.5. And when I multiply this, I do get 32, and 32 equals 32. And that works out. Last problem. Let's do 7x equals 3/4. Now, this one is again multiplying. So we must be dividing. So we're going to divide by 2/7. Obviously, this should cancel out. And divide by 2/7. Now, I'm left with x equals. So for this, you can use, if I'm dividing this one, you can use KCF KCFM. And if you remember from the video where we had to divide fractions by fractions, we used this. So we'll set it up. So it's divide by 2, 7. Remember, KCFM. So I'm going to keep this. I'm going to change this to multiplication sign. I'm going to flip this, which really meant reciprocal, and I multiply. So I get 21 equals 8. And you can change this into 2 and 5/8. That would just be the mixed number. And your final answer would be x equals 2 and 5/8. This is your final answer. Again, if you would check it, you would still get this. You could check it. I don't have enough room over here to check it over, but if you did check it over, it would work out. So hopefully this video helped you. And the next video, you will start to talk about writing equations.